In this video, we're going to be solving a differential equation. We have dy over dx equals y squared divided by x minus xy ln x, and we're going to be solving for y, or we're going to try to find a relationship between x and y. Now, where does this problem come from? This problem was actually inspired by black pen, red pen. Which problem inspired this video? That's for you to find out. But if you can't, let me know, and I'll probably indicate a link in the comments down below. But I'm pretty sure you'll find it. Anyway, so we have the following interesting differential equation, which we can write as dy over dx equals y squared divided by x minus xy ln x. When you get a problem like this, x and y are kind of mixed together. So this is actually a pretty hard problem. It is linear, or is it linear? Something to think about, but it looks kind of complicated, doesn't it? Don't you think so? Okay, so I can kind of tell you how to solve this problem, and then at the end or towards the end, you're going to realize where this comes from, but hopefully I don't even need to tell you. So the first thing we're going to do is probably replace this with y prime. It's going to be a good shortcut. So let's replace it with y prime and then cross multiply. Okay, so we're going to get x minus xy ln x all multiplied by y prime equals y squared. Nice. What's the next thing? The next thing I want to do is distribute. Using the distributive property, we're going to get xy prime minus xy ln xy prime. Sometimes it's better to write the y prime first because I don't want it to mix with ln x. So let's go ahead and write it as y prime multiplied by xy ln x, because I want to keep the xy ln x together, and that's going to be a little helpful. It's going to be helpful in a little bit, okay? So now this is equal to y squared again, and here is the most important move. We're going to try to isolate y prime. So let's go ahead and add y prime xy ln x onto both sides. Then we can write this as y squared plus y prime times xy ln x. Okay, so far so good? Awesome. Now notice that the coefficient of y prime is xy ln x. I want to keep the ln x with y prime. You'll see in a little bit why that's helpful. So I kind of want to get rid of the xy. There's a y squared here, there's an xy prime here, so I'm going to go ahead and divide everything by xy. Divide by xy, divide by xy, and divide by xy. This is going to be helpful in so many ways. First of all, we're going to get rid of the x and end up with something like y prime over y, which is a good thing. You'll see in a little bit. And then one of the y's cancel out, which gives us y over x. That's perfectly fine. And then here the whole xy thing disappears. All right, great. The next thing we're going to do is just write the clean version, y prime over y equals y over x plus y prime ln x. Doesn't this look much better than the original problem? I think so, but we're going to make it better. So the next step would be to write y over x as y times 1 over x, which is correct, right? And plus y prime ln x basically stays the same. Now, here's what I want you to notice. The left-hand side is the derivative of something. Did you figure it out? It's the derivative of ln y. If you know the rules for differentiation, actually, you can't really solve differential equations without knowing differentials and derivatives, right? Obviously. So you'll realize that this is the derivative of ln y. Okay, remember the derivative of ln of a function? Derivative of the inside divided by the function itself. And in the case of ln x, since the derivative of x is 1, the derivative of ln x is 1 over x. Make sense? Awesome. And that knowledge also kind of helps us on the right-hand side. Take a look at this. 1 over x, what is it? It's the derivative of ln x. So we can kind of write it like this. I can kind of switch these around and write this as the derivative of ln x multiplied by y plus the derivative of y multiplied by ln x. What does this look like? If you call this, let's say u, suppose ln x is equal to u, you're going to get something like u prime y plus y prime u. Doesn't that look like the product rule? If you know the derivative of a product, this would actually be the derivative of uy, right? So it means that this expression here is the derivative of ln x multiplied by y. Or you can write it as y ln x if you want. That probably looks a little better. Awesome. We've gotten to a really nice point where things will simplify like crazy. We're going to get rid of all the derivatives, all the differentials. We're going to end up with a nice equation. But that nice equation is going to give us something very surprising at the end, which is going to bring you to the beginning of a video by Black Pen, Red Pen, because remember at the beginning I told you this was inspired by Black Pen, Red Pen, also known as BPRP. Okay, anyways, I'm kind of giving him a shout out even though he doesn't need one. He has over 1 million subs. But anyways, at one point he actually gave me a shout out, so I'm very grateful because that video just blew up. I was a small channel at the time. I'm still a small channel if you consider the number of subs I have. But anyways, that's a different story. I'm very grateful for all the support that he gave me, and I hope he continues to do that. Anyways, so where do we go from here? We can go ahead and integrate both sides, but when you integrate, you got to realize one thing, that a constant will be introduced because the derivative of a constant is 0. So if the derivative of two functions are equal, then they actually are not always equal, but they differ by a constant. Make sense? Okay, great. So we can kind of write it as ln y equals y ln x plus a constant c. Don't forget that because it's worth a lot of points on the exam, okay? So this is a constant. And it's kind of weird that y constant is spelled with a c because, do you know why? Because it's English. There's no explanation. Now let's go ahead and do e to the power both sides. And notice that e to the power ln y is equal to y. So you can kind of write this as y when you do the e to the power. And let's do it on the right-hand side as well. And then we're going to go ahead and separate this into a product. So we can kind of write it like this, right? And notice that if c is a constant, e to the power c is also a constant, isn't it? So I can call it k. It's more convenient, and mathematicians do this. I'm not saying I'm a mathematician, by the way. I'm just saying this is a common practice, okay? Don't get me wrong. And then this is a k. And what about the other piece? That kind of looks complicated, doesn't it? Y mixed with ln x. But don't worry, you're going to use the rules of exponentiation. That's why it's important to know these rules. These are really nice shortcuts. And can I put the k here? Because it's multiplied and it's a constant. So constant has to go first. Okay, let me clean up a little bit, make it nicer. Y equals k times this. Awesome. What is e to the power ln x? You should know from here that is equal to x, right? So we get y equals k times x to the power y. And you're like, so what? Well, this is the solution, right? We've gotten to the end, but not to the end of the video because I still need to show you something, which is actually the coolest part. So stick around, okay? Now, here's the biggest part. Suppose k is equal to 1 or c is 0. Same thing, right? And in that case, then we have y equals x to the power y. And you're like, so what? It's just a special case. But here's the thing. Since y is equal to x to the y, this y can be replaced with this y, which is x to the y. In other words, you can replace the y in the circle that I circled with x to the power y. And guess what? You could keep doing it. Replace y with x to the y and keep doing it. And eventually, you're going to get to something interesting. You know what that's going to look like? X to the power x to the power x. It's going to go on forever. In other words, you will get the infamous, or should I say famous? The famous infinite power tower that rhymes. And this converges for the following interval. It doesn't always converge. For example, if x is too large, like greater than or equal to 1 over. Oops, sorry. Let me rewrite it. This converges for the following interval if x is between these two numbers. If x is greater than e to the 1 over e, it does not converge. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. And thanks to Black Pen Red Pen for the inspiration. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.